Today we're going to talk about bacteria growth and what a million looks like and how that relates to zombies. Be sure to take notes. At the end you'll have a quiz. And that quiz will count in Mr. Heisey's class. So think about these three questions. How big is a million? Could you count to a million? And how long does it take for your heart to beat a million times? So I'm hoping you're really concentrating on that last one. How long does it take for your heart to beat a million times? So let's think about it. All right, so your heart beating, let's think about that. So on average, it beats probably about 65 times for every 1 minute. So that's a ratio, and if we have two ratios, we make a proportion. So if we're talking about the heart beating 1 million times, then how many times is it going to beat? So think about how you would solve that, and then go ahead and do it. All right, so I figured it out, and I got 15,384. So 15,384 approximately. I dropped the decimal off. So that's how many times it would take, or how many minutes it would take to beat a million times. So in hours, we would have to divide that by 60. That would give us 256 hours. So let's find the number of days. So let's divide that by 24 since there's 24 hours in a day. And that's approximately 10.6. So we're going to say almost 11 days. So that's probably a lot longer than you originally thought. You were like, oh, my heart will beat a million times in a couple days. Or maybe you thought a couple hours. However, 11 days to beat a million times, that means a million's really big. All right, so let's talk about how 1 million relates to science class. In science class, you've been collecting samples, and you are growing some bacteria in an incubator, and you want to be able to eventually see this bacteria. And so when you can see it, it means the colony has reached about 1 million bacterium. Bacteria typically reproduce when they reach a certain size. Generally, this happens about every 20 minutes. So originally, we started with 1 bacteria. And then after 20 minutes, right here, 2 more reproduced because the 1 split into 2. And then after another 20 minutes, those 2 will split into 2 more. And then we have 40 minutes, and we have 4. And then here, the last one would be at 60 minutes, and each of the previous 4 split and became 2 more. So at 60 minutes, or 1 hour, you have 8 bacterium. So let's continue the chart a little bit. So if we had 8, at 80 minutes, that 8 would turn into 16. And at 100 minutes, that 16 would turn into 32. And at 120 minutes, that 32 would turn into 64. 140 minutes, do you have it yet? That's 128. And then at 160 minutes, we would have 256. See how I'm doing this? 256 would become 512, which becomes 1024 at 200 minutes. And then we have 2,048 and 4,096 at 240 minutes. So at the very beginning here, like, the first 1, 2, 3, 4, even maybe down to the 5th time they split, it wasn't really growing that fast. But I would say after that, in the middle chunk, it really started to grow and multiply. So will this graph make a straight line? Let's think about it. Well, is there a constant rate of change from each one of these? From 1 to 2, it goes by 1, but from 2 to 4, it goes by 2. So this was 1 change, this was a 2 change, and then this was a change of 4. So the rate of change is not the same. So let's look at the graph. Here's the graph, and like I was saying, the rate of change is not steady or constant. Therefore, the graph will not come out as a straight line. It comes out as this curve, and it is called an exponential growth graph. So this is the exponential growth of bacteria. So how does this relate to zombies? Well, the zombie disease spreads through populations, as well as other diseases. As with all infectious diseases, it's assumed that the zombie virus started with one person who became infected, and then it's estimated that the zombie then affects an average of 2 people per week. The number of people zombified grows and grows and grows. We're going to take a look at some graphs. Before we take a look at the videos of the graphs, let's think about if we have one zombie and every week it infects 2 more. And then after another week, each of those zombies will infect 2 more. Hopefully this is looking familiar. It should look like the one we did on bacteria growth. So this is after 1 week. This is 2 weeks. After 3 weeks, each of those would become 2 more. So after 3 weeks, we would have 8 zombies. So this is also an exponential growth situation. So here we're taking a look at zombies, and the little white squares are people in the population who have not been infected yet. And as they turn infected, or as they're bitten, they turn orange and then immediately turn red after the zombie virus has settled in. So we're looking at the left grid, and those are the number of people in the population that are declining because they're becoming zombified. And on the right, we're looking at the growth graph of how fast they are changing. So this is a virulence rate of 1. So this is a pretty slow process on this graph. So we're also going to take a look at what happens when it's a little faster. So the zombification rate is limited by certain factors, just like with any other disease that we'd be spreading through a population. Okay, so these factors are food source and virulence. Virulence is the measure of how effectively a disease-causing agent can spread through a population. That's very important. Hint, hint, nudge, nudge, wink, wink. That might be on your quiz. And some other factors are the natural resistance to the virus by some humans. So some humans might be resistant to getting it, and therefore they cannot be turned into a zombie. So now let's look at a graph that shows us if there's a virulence rate that is fast. So that one was much faster. And as we got to the end, hopefully you noticed that it went a little bit slower. So as we look in the middle of this graph, right through here, the speed of people being infected by the zombie virus is fast. At the beginning, it was slow, and at the end, it was rather slow. Okay? So at the beginning, it was slow because there was only one person who infected first, and then there was 2, and then there was 4. Okay? But in the middle is when you see very rapid growth. Eventually, the rate of infection of any disease begins to decrease due to fewer and fewer people remaining to be infected with the disease. So that's what we saw at the end of that last graph, where it was really slow and the dots got close together. They were close together because there weren't many people left to be infected, so the rate started to slow. All right, so now it's time to take your quiz. I forgot to give you the Schoology code, so ready for it? You need to join this course in Schoology. Alright, so you might need to pause the video so that you can have the code. I'm not going to continue to show it, but it's JQVSZ9J58T. Join that course, and there's a quiz on bacteria growth. Thank you.